Hello! In today's video, our goal is to find the range of a set of values and make a box plot. Evidence-wise, we're going to make sure that we can sort a series of numbers, just like we did in the previous video. If you haven't watched that video, make sure you go watch it. We're going to calculate the range. It's just a very, very straightforward operation, not too hard at all. And then we're going to use background knowledge to create a box plot. Pretty much everything that you need to know in order to make a box plot, you already know how to do. It's just applying them to that specific thing. Our learning experience is there as well if you want to read it. Otherwise, we're going to move into our first example. So first thing we need to do, if we have some sort of problem with a set of numbers, we need to organize them. So in this problem, we've got Mr. Tekmansky who launches a rocket 7 times. The 7 altitudes are listed there. We need to find the range of the altitudes. Before we can do that, it's going to help if we put them in order. Now, you saw me in the last video put them in order. You're just listing them from least to greatest, so we're going to skip ahead to when they are now in order. 90 feet is, of course, the least, so we're going to have that on the bottom. 115 feet on top, because that is the most. So, as for finding the range, all we're going to do is we are going to take the bottom number, or the first number. This is called the minimum. I'm sure you've heard that word before. It's the same thing in math. And we're going to take the maximum, which again, you've probably heard of, not just in math. Minimum and maximum are two mathematical terms. They mean exactly what you would expect them to mean, so we're not going to spend a whole lot of time defining them or anything. But you can see them there. Nothing too bad. As for finding the range, and I would suggest making sure you write this down if you for some reason haven't written anything down. Range is going to be equal to the maximum of your dataset subtracted by the minimum. So whatever the maximum value is minus the minimum value should give you your range. Make sure you write this down. This is a very, very important equation to know whenever you need to find a range. Fortunately, it's only one operation, so it's not that bad. So our range for this problem, our maximum is 115. Our minimum is 90. So we're going to subtract 115 from 90, and we should get 25. We do have to remember that our units are feet, so we want to say that our range is 25 feet. That's it. That's all you gotta do to find a range. Copy down anything that you need from this slide before we move on to the next one. We're gonna do you do next. Shouldn't be too bad. Our you do for today. The last number of games the Denver Broncos have won in each of the last 10 seasons is listed to the right. So you can see everything from 2020 back to 2011, how many games they won per season.
Oh, the Denver Broncos!
You are going to find the range of the victories. Remember, that means that you need to sort them, put them in order first, then use that equation that we wrote to help you find the range. Pause the video, do this now. So next, we're going to use the same problem that we used from our first example, but this time we're going to make a box plot. There are a few different things you need to know. Let's start by identifying the minimum and maximum. They're the same things as they were before, but it's always good to list them since we don't have them currently listed. The next thing that we're going to need to do, we have this number line here. And it's always a good idea to make a number line first. So think about what your scale is, think about what your minimum is, think about what your maximum is. Make your scale so that it's relevant, that it should fit into that scale. So for example, maybe I want to start with, well, let's start with 70, and we'll go up by 5s each time. So this would be 75. I'm not going to write that one down because I'm lazy. But we'll keep on going up by 10 every 2 spots. We have 130, 140, 150. So, First thing that we want to do is we want to put the minimum and the maximum as points on our plot. So our minimum is 90, so we're going to put a point here. Our maximum is 115, so we're going to put a point here. Next thing that we want to do, you may remember from the previous video, again, watch that first if you haven't, but we're going to need to find the median. If you don't remember what the median is, it's the middle of the data set. So in this case, we would count 1, 2, 3, and this then would be our median. When we have the median, we are just going to draw a line where that should be. Next, we're going to find two new things that we haven't talked about. Those are going to be the first quartile and the third quartile. Make sure that as we go through this, you are writing these down. The first quartile is just the middle value between the median and the minimum. The third quartile, then, is the middle of the median and the maximum. They're essentially the same thing, just on opposite sides of your data set. So, to find these quartiles, we are just going to do the exact same thing that we did to find the median. We'll start at the median and the minimum, and we'll count 1, 2, and oh dear, there's not actually a middle value right here. Fortunately, if we look at the previous two, it's 97 and 99. So we know that Q1, the first quartile, is going to be 98. We're going to find that on our number line. It should be about here. And we're going to draw in a little line for it. We're then going to do the same thing the other direction. So we have 100 and 115, 100 and 110. And again, oh dear, there's no actual number in between these two. But if we use our mathematical reasoning, what's halfway between 100 and 110? It would be 105. So, if we find 105, which would be here, we can draw another line in here. So we now have everything we need to make a box plot. Just to label them one more time, this is the minimum, this is the maximum, this was the median, and then we had our first quartile and second quartile. Okay. The last part of this is just actually making things and connecting them. With your quartiles and medians, you're basically just going to make a couple boxes. They look like this. And at the end of each of your box, you're going to draw a line that goes out to your minimum and maximum. And that's all you got to do. Now this does look a little bit messy. I'm going to clean it up, although all of the other notes are going to disappear in a second, so if you need to write any of these notes down, write them down now. They are going away in 3, 2, 1, and now you can see our box plot a little bit better. Really, these dots should be a little bit bigger, so I'm going to draw them a little bit bigger. But that's what a box plot looks like. You've got the whiskers, you have these two boxes in between, and that's it. I'd usually at this point say pause the video and write down whatever you need, but you already did that. We're just trying to make it look a little bit nicer. So I guess instead we'll just move on to the next you-do. Our second you-do, you're using the same set of data from the Broncos, but this time you're going to make a box plot to represent the data. In the previous problem, you should have organized your data first. If you didn't, guess what you're doing now? You're going to organize your data. Remember that you know the minimum and maximum already, so you just need to find the median, and then quartile 1 and quartile 3. If you're wondering what quartile 2 is, it's the median. That's all it is. So pause the video, give this a try. So things to remember from this video. The range is the difference between the minimum and the maximum. Subtract the minimum from the maximum and then you're good to go. To make a box plot, you're going to need a minimum, a maximum, the median, the first quartile, and the third quartile. All of these you can see over here off to the side. There's a lovely little diagram with some set of numbers. The diagram is a little bit different because it says lower extreme and upper extreme, but it's the same thing. And again, it shows that the median is actually the second quartile if you're wondering where that is. Pause the video, write anything down that you need from this slide. So suggested practice problems for today. We're going to use the same suggested practice problem from the previous video, in that Mr. H runs 20 minutes for 7 days. The distances he runs each day are listed below. Remember that all of the measurements are in kilometers. This time you are going to find the range, and you are going to make a box plot to represent the data. Can you guess what the suggested practice problem for the next video is going to be? Anyway, pause the video, and good luck.